Hey everybody, this is Mr. Storm. In this video, we're actually going to create our Mario character. This is going to be a bit more advanced than really anything else we've done because we need to add the sprites, we need to add animations, we need to add a collider, we need to add script to make it move. But this is the basic steps that we're going to follow. These steps are the basic steps we're going to follow to create every other object that we create in any game for the most part. So let's talk about animation. Actually, let's create our object first so that we're not playing around in this scene. Let's click plus here to create a new scene. We are going to create we need it to be a kinematic body 2D because this is a character that's going to move and do things. So we're going to click create kinematic body 2D. Let's rename it to Mario. And let's talk about animation. So an animation in game development is basically a series of sprites that are played in a specific order at a specific speed in order to simulate movement. Mario, our version of Mario, is only going to have 3 different animations. Sorry, I had to sneeze. He's only going to have 3 different animations. He's going to have a default animation, which is just what's going to play when he's standing there by himself. There's going to be a run animation and a jump animation. And we can create all these animations using the same sprite sheet. Let's go ahead and bring in that sprite sheet. I'm going to grab my folder here. Let's go to Mario Assets. And I have this Mario sprite sheet that we can drag into our art folder. Okay. I want to very quickly turn off the filter so that my artwork doesn't look so gross. Let's take a look at what we have in this sprite sheet. Notice that we have 3 different versions of Mario here. We have little guy Mario, we have big guy Mario, and we have flower power Mario. We're only going to focus on little guy Mario. And we also don't need the swimming animations here. We're not going to deal with the sliding down the pole animation yet either. This starting run animation, that we're not going to worry about. The death animation we're not going to worry about. All we really need are these 4 sprites right here and this jump sprite for our animation. So we're gonna do a lot with just like 5 different sprites. So let me go ahead and delete that because we don't want that there. What we want to do is we want to add a new child node called an animated sprite. Animated sprite right there. Click create. And this animated sprite is going to control our animations for this character. So over here, if I go to frames, I can click this empty spot and click new sprite frames. And then I can edit it. That's hard to say. This dialog looks a lot like our tile map dialog from the last video that where we were actually creating new tiles, but it's different because here, this isn't where our artwork is. This is our list of animations. Right now we have a default animation. And then over here, we have where our frames are going to go for the animation itself. So to create a new animation, we need to, or to add frames to this default animation, we need to click this waffle button that says add frames from a sprite sheet. And the sprite sheet we're going to add from is this Mario sprite sheet. Now, notice that the boxes are not great. They're not surrounding the character like they're supposed to. I've played around with this a bit with a specific sprite sheet, and I found that 27 horizontal and 11 vertical tends to work pretty well. It's not perfect, but it is pretty close to what we want, right? So now these boxes are separated. Now all I have to do is click on one of these to add that frame to the animation. So click on it and add that frame. So now we have our default animation is just Mario standing there by himself. That's an animation. Now you're probably thinking, but you said it was a series of sprites playing in a specific order. In this case, the animation is just one sprite because we don't want him to move. We don't want him to simulate movement if he's just standing there. So let's create an animation for him to run. So to create a new animation, I click this new animation button. I'm going to rename it to run. Grab the same sprite sheet, and it's going to be these 3 animations, or these 3 frames right here for our run animation. So I'm going to click all 3 of those, click add 3 frames. So now we have 3 sprites. If we want to preview what this animation looks like, we can come over to our animated sprite and go to the inspector and click playing, and it'll play. And it looks kind of dopey, right? It's not great. The reason why is because it's playing very slowly. So we can change the speed scale here. If we turn it up to say 3, now it actually looks like a continuous run. It looks a whole lot better. You guys can play around with those settings if you want. I think this looks probably the best. Now, I don't want that playing all day, so I'm going to turn playing off. So the last animation we need to create is, is jump. And this jump animation is just going to be 1 frame as well. Just going to be that frame right there. So now we have default, jump, and run. So very, very simple animator controller. Okay, let's go back to, let's make sure that our animation is set to default so that we don't start with a jump animation whenever the game starts. Now the last thing we need to add to this is a collider. So let's go ahead and add a new collision shape 2D. And the shape we're going to use, instead of new rectangle shape, we're actually going to use a new capsule shape. And here's the reason why. The capsule has a rounded bottom, which is going to make it a whole lot easier for us to navigate. Remember that we created our level using tiles. Those tiles, they should perfectly line up. But if for some reason one of the tiles, the collider, is just a little bit bigger than the other, then if we have a square sliding onto another square, that might get caught, right? So this will allow us to slip over those little jagged edges in a collider that we may have. All right, so I'm going to shrink this down, bring that in about there. Okay. Now, it's not critical that we get it perfect right on his feet. And it looks like for this sprite specifically, we're not going to be able to snap it perfectly. So just get it as close as you can. Okay, now we have a collider. Easy enough. Now the rest of this is all basically going to be programming. So let's add a new script. I'm going to make it an empty and click create. Okay, so before we really get into the script though, actually we need to set up our inputs. So go to project settings and then input map. We're going to need a left, a right. I just mistyped. Right. Let's create a run and a jump. Now you're probably thinking like left, right, and run. Aren't those all the same things? Not really. Left and right are going to handle our movement. Run is going to handle, are we moving fast or slow? Remember in Mario, you can hold down a button, I think it's the A button, to run, and then you push the B button to jump. All right. So left is going to be the left arrow key. Right is going to be the right arrow key. I'm going to make run Z, and I'm going to make jump X. Okay, so those are all of our inputs we need for the game for now. Now we can actually start programming this thing. So first, we need some variables. Let's create a variable called velocity, just like we did with our ball in Pong, vector 2. And we'll set it to 0, 0 for now. Okay. We also need a variable called speed. We'll set that to 40. Now, again, you can play around with these values. These are just the values that I found work for this project, but you can make them different if you want. And we also need a run speed. Basically, our regular movement's going to be 40. Our run is going to be 50, so just slightly faster. And then we need another variable that is a special kind of variable. This variable is going to be an onReady variable, which basically means whenever this object is created, before we do anything else, we're going to do what this variable wants us to do. So onReady var sprite equals animated sprite. So with Pong, we were talking about how if we need to access a child of the root node, then we would use this $sign and then type it out. I found it's a lot easier if we just create a variable that stores a reference to that, and then anytime we want to change the sprite or affect the animated sprite, we can just call sprite instead. It's easier to type. Okay, now we need to make our Mario run. We have the variables we need. We just actually need to make it happen. So there's going to be a lot going on here in just a second. Just please follow along as best you can. First, we need to create a new function, and we're going to use that physics process delta function because we're handling movement. Inside that function, first we need to check to see if input.is action pressed, and we're looking for run. Basically, if we are holding that run button, then we also need to check if input.is action pressed, and we'll say left. So if we're holding the run button and we're holding the left button, then we are going to change our velocity.x minus equals run speed. Okay, we are going to access that sprite, so our animated sprite. We want to flip the H, basically flip it horizontally. We'll set that equal to true. And we want to play the run animation. Okay, so that's what's going to happen if we push left and we're holding run. I'm going to copy that and paste. And instead of if, it's going to be elif. Elif input action is pressed right. Then instead of velocity x minus run speed, it's just going to be velocity x plus run speed. Flip x is going to be false. So if we're running, we want it to actually update. We want it to run at run speed. Now, what if we... Oh, you know what? We actually need one more thing here. We want to play the default if we're not running. So even if we're holding the run button, but we're not, if we're holding the run button, but we're not pressing any of the directions, we still want to play that default. We just want to stand there. Okay. Here's the fun part. All of this is basically the same, except instead of run speed, it's just speed. And that's it. So really, we typed some stuff, but we copy and pasted a bunch. So all we're doing is we're just changing how fast we're going to run if we're pressing the run button. If not, then we're just going to go at a regular speed. Okay. Now there's two more things that we need to do. Basically, in order for this movement to actually work, we need to update our velocity.x by a linear interpolation. Here's what this means. Okay, so let's say velocity.x equals lerp. Lerp is a method that, oh, come on. Let's look at the documentation here. So lerp, it will linearly interpolate between two values by the factor defined in weight. So basically what this means is we're going to go from one value to another value at a specific weight. What this means is we are going to go from fully moving to completely stopping at a specific rate, which means we won't stop immediately once we stop pressing the button. We will kind of slow to a stop, right? It's not something that you're going to be able to notice really when you're watching it, but if you're playing, it's going to feel different if we don't have it. So our current velocity.x is where we are. 0 is where we want to be, and we're going to give it a weight of 0.2. So that's going to calculate our velocity.x to be a linear interpolation between those values. That'll give us a nice slide, right? Or a nice slowdown, not a slide. Slide we're going to do here. Velocity equals move and slide. Velocity vector 2 dot up. So let me explain what this does. So move and slide is going to move the body along a specific vector. And if the body collides with another, it'll slide along the other body rather than stop immediately. That'll give us a nice slide whenever we stop running. The up direction here, so we have our linear velocity, which is going to be the vector. The up direction that we give it basically will tell us which way is up. And for us, it's just going to be vector 2 dot up. We're not changing gravity or anything in this. We're not changing the direction of gravity, I should say. So that's totally fine. We can close out these here. So those two lines of code right there will give us actual movement. Let's save all scenes. Actually, we need to save this one specifically and call it Mario. Okay. Let's go back to level 1.1 and let's bring our Mario character into this level. Click open and let's put him right about there. Actually, I'm going to put him up here. You'll see why in a second. Let me hit play. We'll select the current level. Now look how small our screen is, by the way. That's because, remember, we're making it look like an old school TV. And I can actually maximize it, and it'll stretch my graphics. So, running actually works. Left and right works perfectly. The animation looks pretty good. Now you're probably wondering, and notice that there's a little bit of a, you probably can't tell because you don't know when I'm releasing the key, but he's doing a little bit of a slide. There's some momentum at the end. All right. Anyway, you're probably wondering, why is he not falling? Well, it's because we haven't added gravity yet. So we're going to do that in the next step, but at least we have left and right movement. Okay, let's handle jumping. Let's go back to our script. Now, to jump, we need to do quite a few things. Now, it would be just pretty easy just to say whenever we push a key, we want Mario to go up, right? But the problem is Super Mario Brothers, as a game, really kind of changed the industry when it came to movement and control. Jumping was something that was really hard to get right, and Mario got it really right. So there are some things that we need to do. First, on a natural jump, you are going to be moving faster at the beginning of the jump and at the bottom of the jump. But in the middle, I'll use my Mario here as an example. So you're going to be moving faster on the up. In the middle, you're going to be slowly moving as gravity takes hold, and then you're going to be moving faster on the down, right? So that's kind of how a jump normally feels in nature. If your jump has the same consistent speed all the way through, it feels really floaty and it feels like gravity's not acting on that thing, right? So we need to change that. We need to make it so that we're pulling down on the end. We also want to be able to vary how high Mario jumps. If we just tap the button, we want him to jump. But if we hold the button, we want him to jump higher, right? So those two things are going to be things we need to integrate into our jumping mechanic. So first, we need some gravity. So var gravity, and we're going to call this 20. And right here at the top, we're going to say velocity dot y plus equals gravity. So basically gravity is always pushing our Mario down toward the bottom of the level. Okay, now we need some other jump variables. So one is a fall multiplier. That is going to multiply our falling speed so that we have more weight on the back end of our jump. We're going to have a low jump multiplier, meaning if we just tap the button versus if we hold it, we're going to multiply it by a certain thing. We need a jump velocity. We'll set that to 400. And then we need an earth gravity. Now, you're probably thinking, we already created gravity, so why are we creating a different thing called gravity? Here's what we're doing. This is important for the physics calculations we're going to do here soon. And so we need what actual gravity is on Earth versus what gravity is in the Mushroom Kingdom, right? So just think about it like that. So Earth gravity and then our Mushroom Kingdom gravity. Okay. So with those variables, we can actually start creating some jump mechanics. So let's do this right below our gravity statement. We'll say if velocity.y is greater than 0. So if our velocity is greater than 0, then velocity plus equals vector 2 dot up multiplied by earth gravity multiplied by fall multiplier. Okay, so what this is saying is if our velocity.y is greater than 0, meaning we're moving down. If we are moving down, then we want to change our velocity to be our vector 2 dot up multiplied by the earth gravity and our fall multiplier. That's going to make it so that we're falling faster than we were jumping, okay? We're going to make an elif, meaning that these logical statements are going to be together. Velocity dot y is less than 0, meaning we're moving up, and input dot is action just pressed. Hold on. Just pressed. No, we'll do just released. Is action just released jump. So what that's going to do is it's going to say, all right, are we moving and are we going up and did we just release the jump button? If we did, then we want to change our velocity to plus equals vector 2 dot up multiplied by earth gravity multiplied by low jump multiplier. So that's the thing that's going to allow us to change whether or not we're doing a tiny little jump or a giant jump, right? Okay, so these things are going to calculate our velocity for us depending on the situation, but it's not actually going to do anything. What we need to do is we need to change, we need to allow ourselves to jump if we're not on the floor. So what we can do is say if is on floor. So if we're on the floor and if input dot is action just pressed jump, nope, not jump velocity, jump. So if we're on the floor and we just push jump, then we want to jump. Velocity equals vector 2 dot up multiplied by jump velocity. So we're going to actually, this line of code is what actually makes us jump. Okay. Then we need to change our animation so that if we're not on the ground, then we are going to be doing that jump animation. And we're actually going to do it down here at the bottom. The reason why is because we want to allow these, we want this to overwrite any other animations that might be playing in the game. So we'll say if not is on floor. So if we're not on the floor for any reason, whether it's jumping or falling, then we want to sprite, play, jump. Okay, perfect. That is our entire movement script right there. That's jumping, that is running, that is walking, and animations, and then actually updating our velocity and making things move. So let's save that, save all scenes, and let's play our game and test it. Okay, so let me maximize. Now notice that my Mario is actually on the collider. It's on the floor. I'm running. Okay, I can actually go a little faster when I run. Cool. I can jump. I can jump a little higher if I hold the button. If I tap, I just go there. And again, we can play with these values later. Okay, so that feels pretty good. We have a good jump mechanic. The last thing we need to do is we need to set up a camera so that our camera will follow our Mario properly. So let's create a new camera as a child of Mario. So create a new child node, and this is going to be a camera 2D. And we need to fix this camera so that first it's the current camera in the scene, so that that is going to be our viewpoint. And we need to change the limits here. The limits of this camera will mean that the camera can't move past certain spots. So for the left, we're going to set the limit to 0. For the top, we're going to set it to 0. For the right, we're going to set it to 3350. And for the bottom, we'll set it to 240. What this is going to do is when we play the game, the camera's going to stay locked into this space, and it will not leave that area. It won't leave the boundaries of our level. So let's test it. Okay, so now I can run, the camera follows. Oh, you know what? I still have my guide on. Let's turn off the guide so that we don't get confused. All right, once more. So Mario's running. I'm holding the run button, by the way. If I didn't, then it would be a little slower. I might actually tweak that just a little bit so that it's more obvious. Oh no, I fell. We're gonna have to handle what happens if we fall down those gaps, but we have a game that actually kind of functions now. It actually kind of works. So that's pretty much it. Once you've gotten to this point, you can sign off the first check of this or the first assignment of this project. Just show me that you have a level that works with colliders and your Mario can run around in the scene and everything else. Once we're there, then we're good to go and we can move on to the next stuff. So thanks for paying attention, and I will see you next time.